Hey everyone, you had an assignment. Your job was to think of all the different ways we could store energy in this ball. We're going to go over a few of them and let's see what you think. The first thing we could do is we could take this ball, apply a force to it, and move it upwards. So now this ball has been moved up. We would say that this ball now has energy stored gravitationally. Symbol we're going to use for that is EG. Next way we can store energy in this ball is we could just, throw it. Now this ball is moving and flying through the air or something. Say that this energy is stored kinetically. EK. And this is just energy stored whenever there is motion. Next thing we could do is we could take this ball and could rub it back and forth along the surface. If we apply, and there's friction here, right? Now, when we're all done, our ball looks the same, but how is it different? It's now at a higher temperature. Say that this now has more energy stored. Remember how? Thermally. ETH. Couple more. If we take this ball and we squish it, depending on what the ball is made out of, if it's made out of rubber or elastic or something like that, we can actually store energy in the ball when it's squished. This is energy stored elastically. Symbol we're going to use for that is EEL. Sometimes you'll hear me call it E spring, energy stored in a spring, because a spring is the same idea. You have a spring, you can stretch it, and now that the spring's stretched, it stores energy. You can also have a spring and you can squish it. That now stores energy because it's squished. Either way, any sort of change in shape can store energy elastically. One more. If we take this ball and light it on fire, we're left with a pile of ash. This pile of ash has less energy. What? So wait, where was the energy stored before? If there was more energy here than here, it means it lost energy from somewhere. The energy that it lost, we would say, was stored chemically. ECH. All right, so a quick example of what you're going to do with these. Let's say that we go ahead and we have a, um, sorry, I got a kid crying at me. Let's say that we have a ball at the top of a ramp. Here, the ball is not moving, but we're going to look at this ball three different places. Presumably, it'll be moving a little bit faster once it rolls down to there, and a lot faster once it rolls down to there. When we draw energy pie charts, we help us envision how the energy is being stored in the system at that moment. So at this moment, our energy pie chart for this spot right here, it's storing energy gravitationally because it's up in the air. Someone had to pick it up to put it up onto that ramp. And when they did that, they stored energy gravitationally. As it's rolling down the ramp, though, it's not as much stored gravitationally. A bunch of that energy stored gravitationally is gone. So where is it now? Well, see, it's moving now. That energy, instead of being stored gravitationally, is now stored kinetically. Finally, at the end, it's lost all of that height from the ramp. There's no more energy stored gravitationally. All of this energy is now stored kinetically. So that's just a quick introduction to energy pie charts. Your job today is to work on worksheet 1, and I believe the other one's 1B. Maybe this one's 1A. Do this one in class. Whiteboard it, talk about it in your groups, see if you can kind of get established into what the right answers are for this one. They're pretty quick. They're not too difficult to do once you wrap your head around it. But that said, make sure that you all agree on the answers. 1B will be homework. Sorry. 1B will be homework. And that will be due tomorrow. Tomorrow you will whiteboard that. So your job by the end of tomorrow is to have both of these complete and both of these whiteboarded. All right. Thank you very much. Have a nice day.